The Rock Whisperer. Do you hear the earth talking to you?
The Weather Unit, Weather Fronts 5-5. So in this particular section, we're going to talk about frontal boundaries, and we're going to talk a little bit about pressure systems also. So fronts have to do with air masses. An air mass is a large body of air that has the same moisture characteristics throughout, which sometimes can relate to density, and that air mass will also have the same temperature characteristics throughout the entire air mass. So air masses are really large bodies of air over entire states or multiple states. Frontal boundaries are the transition zones between two different types of air masses. So a cold air mass and a warm air mass. So you'd have a frontal boundary between those. And we'll talk about the differences between the different types of frontal boundaries and how they divide different types of air masses. So here is something that we can see, because we'll start talking a little bit about winds in here. We have low pressure. We said that brings us stormy weather that's going to be associated with a cold front. And we also have high pressure. But we can see with this high pressure, winds are going counterclockwise, and they're kind of going in an outward direction. Over on this side, we have low pressure. The winds are going counterclockwise and a little bit towards an inward direction. We also need to realize as winds blow out of a high pressure system and they move into a low pressure system. Our first frontal boundary is a cold front. So right here is the boundary with the correct symbol, and we'll get more into the symbols, what they all mean, and they're also on your reference table too. So what you have is you have some relatively warm air on this side. On the other side, you have, and hopefully you can kind of see it here, a gently, relatively steep slope in the beginning, moving back, and you have cold air. That cold air is pushing into the warm air, and because the cold air is pushing into that warm air, it's called a cold front. What happens at that frontal boundary is that cold air pushes in, cold air is more dense, that warm air gets lifted up into the air, and when that gets lifted up, we go through that whole cloud process again that we talked about earlier. You have warm air rising. Once that warm air rises, it starts to expand, it cools, and when it expands and cools, we start to have condensation on those condensation nuclei, and that's a key part, the condensation nuclei. In this particular case, we have cumulonimbus clouds in this particular diagram, and that will be a telltale sign of severe weather, thunderstorms. Cold fronts can also bring squall lines, very intense or strong thunderstorms, also associated with tornadoes from going back to the BBC video that we watched. The other main type of frontal boundary is a warm front. So on the back end of this cold air mass, here, really gentle slope on the back, you'll have warm air sometimes. That warm air pushes and gently rides over the tailing end of the cold air. And as that's happening, again, same thing as we just talked about, that warm air is rising, but it's rising very gently and at a slow rate, so we can have a bigger area of precipitation with this warm front. And again, it shows you a variety of different clouds that are occurring as depending on where you are in this particular section. So this line here could take up several hundred miles out in front of that warm front. There are two other types of boundaries that we can talk about. And another one is going to be what's called an occlusion or an included front is the other one that you will see. And what we have here is you have a warm air mass from your warm front, that's right here. Then what happens is you get another wedge of very cold air. So this cold air is more dense and colder in temperature than the preceding cold air, and that cold air mass is going to push into that. We have a warm front. That cold air mass is going to push in and push everything up. So you're going to have a very big line of storms or rainy weather that will occur with that. There is a fourth type, which is stationary, and there's no movement in that one. You have cold air pushing into warm air. They're both relatively about the same density. They're both relatively same amount of moisture. So let's look at some of the symbols. The cold front is going to be triangles. The warm front are going to be half circles. The color is important too if we're looking at a color picture or you're drawing something and you're told to do it with color. Cold front, blue. Warm front, red. We talked about the occluded, where we have the cold front pushing into the warm front, so it's every other. And stationary means they're moving in opposite directions, so the triangles point one way, the half circles point the other way, indicating that you have air pushing in those two different directions and it's stuck, it's not going anywhere. Please be really careful when you draw. I kind of joke at times, draw monster teeth for your cold front. Make sure they're jagged and pointed compared to your warm front, which are more rounded. So this is how they may look on a weather map, and the arrows are indicating which way the air might be flowing along those frontal boundaries too. I talked about the air kind of pushing into each other here, but we can see that they're alternating. So if you draw a cold front, there's a line dividing the cold air from the warm air, and it's showing you which, these actually show you which way the front is moving. Same thing here with the warm front, stationary front, and the occluded front. Another way to look at this is when we talk about low pressure and high pressure. High pressure means good weather. So we can see that high pressure, it's coming downward, and when it comes downward and hits the ground, it's spinning in a clockwise direction. So if you actually take your hand and push down, your right hand and push down, your hand is going to tend to go in a clockwise direction, similar to this picture here. Where on the other side, low pressure is doing the opposite. Your hand's on the table and you pick it up, it's going to go in a counterclockwise direction, and that is going to be warm air lifting up into the air. And again, I've said it a couple times already, but that's that whole cloud formation. Warm air rising. When it rises, it expands and cools. We have condensation that occurs on condensation nuclei. And then when we have enough moisture in the air, we have precipitation. Here's an example of a weather map that we have kind of similar to what we've seen before. Shows you your low pressure. You can see here with your low pressure that you have, and I'll draw in here that we can have, what you would typically have is, if we had temperatures, we'd have our cold front that would run through here, and then out in front here we would have our warm front. And then this area here is kind of moderate in temperature. So this shows you what, for a wind chart, it actually gives you the numbers. We can see counterclockwise direction around that low front, high pressure, going in clockwise again.
Don't forget to listen to the earth. You just may hear it speak.